So for today, we are still going to be using this interval notation. We're going to talk a little bit about domain and range still. Those will be in our problems. But we are going to focus on a couple new things. The first of the new things is increasing versus decreasing functions. So here's our first vocab. An increasing function, or a function is increasing. Now this is the formal definition. It gets a little wordy. It says if the y values are increasing as the x values are increasing, then I have an increasing function. This, in other words, if we read like a book from left to right, the function is going upwards from left to right. That looks something like this. Remember positive slopes versus negative slopes? This would be like a positive slope. The other side, the opposite, is decreasing. Oops. Again, it's got a kind of wordy definition, formal definition. The formal definition says that the y values are, decreasing as the x values are increasing. So they're opposites. In other words, this is the more loose definition that we're probably going to see more often. The function is going down when we read like a book from left to right. So it'll look something like this. The last option that we are going to see is something called constant. If I have increasing going up, decreasing going down, what do we think constant looks like? A flat line. So maybe make yourself a little note. Constant is when it is just like a flat, straight line, something like this. Okay, so we're going to do a quick run through of these first 4 parts because we've already done these before. I'm going to try to mark up my graph as little as possible because I'm about to do a lot of marking. The first thing here is the domain. Domain left to right. We're going to start at -4. I need to change this as well. I'm going to start at -4. And it's going to go all the way until +10. I see filled in circles on both of those, so I'm going to use brackets. Am I speeding too fast through domain and range? Then I'm going for range, bottom to top. The bottom looks like it's at -3. The top looks like it goes to +6. And again, I'm going to have brackets. Been a minute since we talked about this, but we should still be familiar with these terms. X-intercepts are where we cross the x-axis. Y-intercepts are where we cross the y-axis. I'm going to write these as points. So for x-intercepts, this first one looks like it's at about -2.5, 0. It looks like I have another one at 2, 0. And it looks like I have a third one here at 8, 0. Does anybody want to tell me what the point is for the y-intercept? Chaz?
0,2.
Perfect. Those things are familiar to us, yes, nothing crazy new. Here's the new stuff. Now I'm going to talk about what intervals of increase, decrease, and constant are. For these 3 topics, we will always use parentheses. Always. I'm going to separate my graph, and I find it helps if you literally use your hands to kind of cover stuff up. I'm going to separate my graph into the different sections of it. So I'm going to do this with a highlighter first. I don't recommend using your highlighter. I recommend using your hands, but for the sake of writing on the board, I see a section here between these 2 sections. I see another section here where it starts to go down. Oops, it's going to let me draw. Oh, there we go. I see another section right in the middle here, and then another section there. So I see a total of 1, 2, 3, 4 sections. Does everybody see those with me? So now we're going to figure out whether each section is increasing or decreasing. Let's take a look at this first one that I boxed in. Do we think this is increasing, decreasing, or constant? Looks like it's increasing. I'm reading from left to right like a book. It's going upwards, so I'm going to call this an increasing interval. So I'm going to write this in interval notation, -4 to -1. We are always going to look at the numbers on the x-axis for these. So maybe it helps you write a little note or look at the x-axis. This is between -4 and -1, and we're using parentheses. Good? Look at this next interval right here. Increasing, decreasing, or constant? Decreasing. So I'm going to put this in the decreasing section. From -1 to 5. Look at how these are nicely highlighted for me because I did that. So I'm going to put a decreasing interval from -1 to +5. What about this guy right in here? Constant. It's flat. So I'm going to go ahead and do another interval for constant from 5 to 7. And then what about this last guy right here? Increasing. It's going upwards as we read from left to right. So here's a little notation thing. If I have more than one interval in an answer, so like in letter E, because there's 2 increasing intervals, I'm going to put this big capital U in the middle. U stands for union. It's kind of like the math term for the word and. So I have the interval from 7 to 10. Any questions on that? That's increasing, decreasing, constant. I'm going to throw one more new concept at you. I'm going to erase what I have right now. So kind of reset my graph a little bit. Maybe, if it wants to. Okay, there's my graph. And now I'm going to talk about whether the function is positive or negative. Okay, here's our last concept for today. If I take a look at my graph, I'm going to have numbers that are positive. Let's do this in blue. Numbers that are positive are the ones that are above the x-axis. Positive. Numbers that are negative are below the x-axis. And then what do we think its value is at exactly 0? Or sorry, I guess the x-axis. At exactly on the x-axis, it's neither positive or negative, it's 0. Okay, so here's what we're going to do. I'm going to kind of use this extra space down here to kind of help me with my positive, negative area. Positive, negative. Oops, if I can spell. The first thing that we're going to do is separate by the x-intercepts. So I'm going to take a look at my graph here. Every single place that there is an x-intercept in this graph, I'm going to draw a section. So there's an x-intercept there. Here's an x-intercept right here. Here's another one right here. You guys, if you cannot be quiet in the back, I'm going to kick you out. Okay, so now do we see how I've separated them by the x-intercepts? So now every single one of those sections is either above or below the x-axis. Yes, we see that. So let's talk about whether they're positive or negative. Right here in my first section, it's below the x-axis, so it's going to be negative. I'm above the x-axis in the next section. That makes this positive. Below the x-axis over here makes this negative. And above the x-axis in my last one is going to make this positive. So 4 sections, they're alternating. This doesn't always happen, but it's good to see that in this one they do alternate. So I also have a lot of different weird things that are going to happen here. When I write my intervals, I'm going to have a couple different options. Either it's going to end with an arrow, which means I'm using an infinity symbol. And when we write infinity symbols, what do we always need to use? Brackets or parentheses? Parentheses. If I have a closed circle at the end of my interval, what are we going to use? If I have an open circle at the end of my interval, what am I going to use? And then the last one, this is unique to positive or negative. If the end point of my interval is the x-intercept, I should technically be using parentheses because at that point, it's technically not positive or negative, it's 0. So this is a good little cheat sheet. We're going to have arrows for infinity, which means parentheses, closed circle brackets, open circle parentheses, x-intercepts, always parentheses. Okay, so that being said, let's determine our positive and negative intervals. This first one right here, we said it's negative. It's starting at -4. I should zoom in. Starts at -4, goes to about -2.5. That's going to be in the negative section. And then remember all these rules I just told you. So I got a closed circle here. That means it's going to get a bracket. And then 2.5, this part right here, you can kind of see it. Is that going to get a parenthesis or a bracket? What do you think? Parenthesis or a bracket on 2.5? Sarah? Parenthesis. It's an x-intercept at -2.5. So that's a parenthesis. Perfect. Okay. The next section I'm looking at is this guy up here. It's going to go positive. So I'm going to go from -2.5 to +2. Brackets or parentheses?
Parentheses.
Why?
Because they're both x-intercepts.
They're both x-intercepts. The next section right here, I'm negative again. So from 2 to 8, I want a negative. I'm going to put a U in the middle for union. 2 to 8. Brackets or parentheses? Parentheses again because I'm looking at x-intercepts. And then the last section is this guy up here from 8 to 10. It's positive.
No, one's a parenthesis.
One's a parenthesis. 8 is an x-intercept, it gets a parenthesis. 10 is an endpoint with a closed circle, so it gets a bracket. I am going to be a little bit lenient on these guys on your quiz, so don't worry too much about it, but these are our rules right here, so I really suggest you remember those. Are you ready for the next one? We'll go a little bit faster. You need a second? We're good? Okay. All right. Let's do domain and range. Can somebody tell me the domain really quickly? Domain? Somebody give me the domain. -7 to 7. I got closed circles, so I'm going to use brackets. Range, anybody want to give me that one? Again, closed circles, so they get brackets. How many x-intercepts do we see on here? Just one of them. I'm going to say that this is -2, just to make it a little bit easier. Let's call that -2, 0. What about our y-intercept? What's our y-intercept? 0,3. Okay, those are the first 4 sections. For E, F, and the second F, increasing, decreasing, constant, what are we going to use in our interval notation every single time? Brackets or parentheses? We're going to use parentheses for these 3 every single time. So I'm going to figure out where are my different sections. I use my hands when I'm doing this on paper to kind of block off where these sections are. There's a section, there's a section, there's a section, there's another one. What do we think? What's this first interval, increasing or decreasing? Or constant? On the left-hand side, what do we think? Jaden? Okay, hold on. -7 to -1. You said there's a union because we have a second one. What's the other one? 1 to 3. Perfect. I like those as my 2 increasing intervals. Next. Anybody want to try the decreasing ones? Where do I see decreasing? There's 2 of them. The decreasing? Maybe I highlight them for you. Those 2 are going downwards from left to right. So what are those intervals that are decreasing? From what to what? James? -1 to 1. There's a second one, so I'm going to use a union. And then 3 to 5. This last guy on the right-hand side, it's a flat line. So that's going to be a constant interval. We're going to say that that goes from 5 to 7. Everybody with me? Okay. I'm going to erase my markings. Now we're going to talk positive versus negative. Where does it change from positive to negative? Where am I going to split my graph up? At -2, at the x-intercept. So I have two sections. The first section on the left, is it positive or negative? It's negative. So I'm going to write the interval from -7 to -2. What do we think? Brackets, parentheses? One bracket because I have an endpoint with a closed circle. One parenthesis because I have an x-intercept. What about this second section on the right-hand side? It goes from -2 to +7. Brackets, parentheses, one of each. One of each. What comes first? Beautiful. Any questions about those? Okay, the last thing, this is like the last thing that's going to be on your quiz, is a word problem such as this in example 3. We're not only going to have to identify like what they're asking us for, but we also kind of have to explain it in the context of our problem. So let's read. It says, one day, Stephen made a trip to Moreland Golf Center in hopes of buying new golf clubs to improve his game. On his way home, Stephen stopped for some ice cream. The graph shows Stephen's distance from home. So letter A says, what are the x-intercepts and what do they represent? Hopefully we can see them. There's two x-intercepts. James? Yeah, so they're located at 0, 0 is the first one right here. And then 15, 0 is the second one. And it represents Stephen is at home. This graph represents his distance from home. So if his distance from home is 0, that means he's at home. The next section, letter B, says, on what intervals is the function increasing? Does somebody want to tell me what that increasing interval looks like? Jaden? I think it's to 5, but yeah. 0 to 5. And what does this mean in terms of what Stephen's up to? Where is he going? Well, I'm just talking about this increasing part. Is he going towards home? Is he going away from home? What's he doing? He's going away from home. In this specific case, he is going to the golf center. Letter C asks, on what intervals is the function constant? I see 2 of them. Somebody want to tell me what they are? 5 to 9. And what does this mean? What is he doing if his interval is constant? He's stopping. On what intervals is the function decreasing? So that's whatever's left over, right? Here's decrease. Oops, that was supposed to be red. Here's decrease, and here's decrease. So that looks like it's going from 9 to 11 and 13 to 15. Oops. And what does it mean when his interval is decreasing? He is going home. So that's the kind of explanation I expect on your homework today. Your homework is in your packets. You have 2 pages because there's 4 problems. Oh my gosh, it's 4 problems.